already explained that I read whole through this chapter, and I found, oh, we already did. So I found that this is very good because it supports Xanadu. Because if you look at this one, every topic in here actually we implement based on their suggestion or their argument. So I recommend, we are nothing to do with this author, but I like this bit because they support Xanadu implementation. So basically, I will shortly say that the Xanadu functionality is enabled to what? Competitive big data management in cloud or enterprise. So basically, one part is any part, any size, any type of the data, but specifically we are targeting, say that, huge volume, high speed data, heterogeneous data. So we are targeting like an image and video data from IoT or other application. And then another side is the handling this one is update, access, retrieve, that we provide high throughput, low latency data access. So this is functionality one measure, you how to provide your value through this handling of your data. But this is just one value. And then additionally, we provide like ACID compliance, data de-rification, and lification. The ACID compliance is basically, I'm not going to talk about detail in that address, basically provide you reliable data even with some part of the system port. The system port coming from this distributed system. You connect multiple servers, right? So there is a chance to increase some part of your server's storage will be fail, but disconnected or the system fault or whatever. Still with that, you will have reliable data. Means that, for example, that you have bank account, and then several clients want to see the current status of your bank account, and then during, for example, during you updated your amount of your bank account, something happened, and if somebody in different place see the different amount, it will be problem, right? For the financial thing, or another is healthcare, right? It's like a mission critical thing. So we guarantee that in any situation that you will see, and every client see the same status, right? That's the one, the very, very important thing. This is one actually in this community, in the data management side, this is very difficult with the distributed system because previously you have one system, one server, and your data management system handle this station, but you have a multiple with what? IoT, geographically different space, right? So to provide a consistent, reliable view of your whole data through a different system is very, very hard topic and very difficult. And we have this developed implementation, and then we have one core competence of this space. And then, for example, actually recently we also provide more stronger globally. That means that geometrically different price globally have a consistent data. We actually implement the technology from consensus technology from blockchains. So yesterday I talked with someone from SAP, and then he said, "Oh, we are developing based on some consensus in the blockchain." He said, "You know that the problem with the blockchain is speed." I know that because the problem is that everybody should be consensus, right? To be conclude your transaction. The way is that you have a mining. So that means that every node have some agree about that, and then one of the algorithm is a proof of works that require every node to accept. Take 20 minutes, 30 minutes, something like that. So that's why that recently actually the actual implementation of blockchain is not that system. They have a separate central mining system, and they have a huge complex of the like a special purpose processor, like an FPGA something like that, and then put in like a data set type. They do that. It's not the original concept. Like everybody join, right? Do some transaction. So we know that problem. So we have a special architecture that to avoid that problem. So we only have from the good good pictures from the consensus algorithm in the blockchain, but we handle the speed. So that's one actually we have know-how, and then we are preparing pattern for that. Okay, so this is one actually. We have good performance, right? Because a lot of people in this community show this, so we did. Right? This is industry standard. It's like it's average throughput, latency, or scalability, or whatever. So you can test in the Amazon cloud, right? So you link to connect a lot of the clusters, and then test about whether how much you can increase your data scalability, the storage device. So basically, we don't have any limitation. We can theoretically include, right? The current version is 64,000 nodes can connect, and we have a developing called Xanadu Next is unlimited, but there is some saturation because you're learning the network problems and so like that. But anyways, this is one measure, and how much the throughput and latency. We are better than any other existing, yeah. But okay, so I will show it's a fault tolerance. Basically, the fault tolerance means that I show that you have linked the different storage servers, right? Multiple. Then even some part of the storage system is failed, you should still extract data, right? Store the data. That's fault tolerance. We have a very strong fault tolerance. So this is an example that you have connected 5 storages, and then you have a replica means that you duplicate 3 times, and then even 2 storage devices completely gone at the same time, you still extract data. And then additionally, we have auto healing process that during time actually you put in another hard driver. We are we call the light adding system. So that's one we're developing some system actually based on this one is that you have a file 2 hours, just put it automatically have the function, and then the other part we require the replica to another storage, so automatically. So I don't want to spend too much time. Okay, so use case, we are targeting that some use case by this integration. So as I told you, it's a composable architecture. The purpose is to developing use case in the space that Xanadu have a core competency. So for doing that, actually, we need other systems. So we integrate big data IoT infrastructures, and then this is our architecture, and this is the other big data application. So we are doing is a total integration to generate some use case. So we are talking with some end users. For example, we are talking with some end users in medical case, and then talk with some of the smarter cities, and then some scientific purpose. Okay, this is one actually we tested our idea. Is that basically here is one point is everybody said about in this community is a commodity device, but actually we are actually commodity device because we integrate the storage system you can buy in Amazon. So in this space, a lot of people are from the environment have a data center has a big an expensive server storage device. They call it a specially designed. And then what they mean by the commodity is not specially designed, but still expensive. Right? What we mean by the commodity is you can buy in any place. How? Because our strong fault tolerance and performance to increase by this software. So this is one test that actually you can buy in Amazon. So put in the server hard driver with top of that have some processor, and then integrate with our system, and we tried to data store and extract because of targeting like a micro data center. So we already launched this project in collaboration with some university, and I give them a project that if you develop this one, this is money. Right? So what I'm doing is we are targeting lower end performance device boosting by our software. So what they're doing is to have all the PCs from the university, 100 PCs, very low performance, right? We are only require is Java, so we only need is learning top of that Java. So if you have can install Java, that's okay. And then we just measured how much in the lower run that we can lower down the spec of the hardware to implementing our software to handling big data. So we are targeting like, for example, this micro data center based on traditional PC. With, you know, the traditional PC with low capability means that you can refresh anytime, right? So that means you don't need a lot of the like additional cost, like provide like heating, cooling, like consistency, like humidity, whatever, the data center environment, right? Power, whatever. So reduce down also supporting cost based on this one, because every element is very cheap, so you can refresh anytime. And then have how they can be do. So we are still waiting for that the low down more the commodity hardware, but we are targeting like this 5 of the package of the hard drive. On top of that, we have one CPU, have a unit of the virtualization of this for the 5 CDs, 5 disks as a different storage system, and then we are pricing them as like 1 terabyte, so 5 terabytes. So what you think about is a step of the 5 terabyte to 5 terabyte until like 100. But the problem may be not this storage performance, maybe the network. So in the network side, we are going to be like at least the 1 gigabps network Ethernet. But otherwise, this device performance, whether CPU or the RAM, and then device, we have low down. This is one we are targeting. Actually, we are doing that. Okay, this is a good example that actually implemented in South Korea. And this is high school PC computing room. So every PC don't have anything in there. They don't have any operating system or any software in their site. Every software is stored in the cloud server in remote place. And so what doing is that Xanadu have a storage that management. So we have a window boot system driver image file. It's around 40 gigabyte. So stored in remote site using the Xanadu. So we have a distributed servers, and then they have a protected space, have a Windows and other application software. And then the users want, they just connect, and then they will extract the data, and they automatically boot in here. So here's one example that we can boot 40 PCs at the same time from remote. Correct. So this is one good example. For doing actually the two general functionality is verification. We have also time stamping. So we have a nanosecond time stamping. Actually, that's one we can apply is like a fast streaming data in IoT application, because we can handle in time series in a nanosecond level. And then by doing actually what you have is that you can have a snapshot in any good like state, right? And then something happens, and you can roll back, and then restart your PC from the good state. So byproduct of this is, fortunately recently there was a ransomware. Right? We don't have anything your client side. So even during you doing some word process, by any chance you're infected, right? But you can lose just for the data, right? But others still safe. So our system, you just turn off, turn on, that's it. And then it will be automatically boot again from the good state. So this is one that we have in relation with the recent have security issues. So this is one good use case based on this Xanadu performance. So we also have another performance that with respect is that we have a de-duplication. That means that we don't store the redundant data. So you can save a lot of the storage space. So for example, that you have a multiple of the series of the window boot master image file. You have an initial, next one, next one. If they have the same component, they will not store 2 times. So they have an initial one, additional one, just additional part store. Right? It's a de-identification. This is one good performance that measure that we save the storage. Okay, finally, what we are doing. This is the one based on, as I told you, we talk with several end users in the medical space and smart city space and some scientific computing space, that we have some agreement about the interest, the mutual interest, that how we can exploiting our Xanadu. All are involved image and video data, real streaming data. And then, for example, one example is the talk with the university hospital, that in the future, maybe they require like real-time decision, the medical diagnostic or the medical decision supporting system. So we want some pilot. So I don't know about the whole system, but I talked with someone in professor in medical school. He said, oh, maybe we have this. I don't understand what the actual system, but at least I know that there is that kind of system to produce real-time streaming video or image data related to some medical diagnostics. And then in the future, maybe like during your diagnostic or the surgery, then maybe they can have implemented deep learning with our system to analyze some situation and provide the real-time decision-making support. It's up to doctors, but anyway, they may be useful. So that's one, the targeting now. And other topics is like a smart city, like a public transportation monitoring and a predictive system type video. And then also thinking about some huge astronomical data, like a classification of whether there is ET or not. Actually, basically, all these developers originally have involved in the kind of ET process. So this technology is actually based on astronomical huge amount of data processing. So anyway, so we are developing that we're using deep learning for Java library, and then you can have several architecture, but we use the famous, we're starting with famous RxNet CNN. If you type Googling, it's famous. It's one of the winning that in competition. And then we use multiple CPUs and GPUs. And then we also integrate Hadoop in distributed computing way. And then based on that, we are integrating with the Xanadu as a file system with this deep learning library. We are also implementing with the integrated currently map reduce for the batch process. And then we also thinking about to integrate other real streaming analytic system like Sparkstorm Flink. So this is undergoing because we already have end users and then they are interesting. So we try to do integration. Once we have done, then actually we are targeting some specific model. So we are going to do some specific model and then show them some demo. And then after that, actually, we need a partner, right, to involve this actual project. Until the time, actually, we spend deep learning and Hadoop, other system, not our business, but for the create value to show developing the good use case. Actually, we touch that area. So we are not actually developing the other side of the system, but at least we integrate them to have a maximum performance with optimized with our system. That's the one we are doing now. So that's why I come here to want to hear about your idea, and then potentially that if you're interested in the future as a partner, then we are developing the use case integrating STEM, and then you have a good business case, or whether if you can participate in part of this process, and then we can be a good partner. And that's it. Thank you.